5 circles are adjacent. They are bounded by straight lines and circular arcs. What is the total length of the perimeter? It looks a bit hard at first, but once you spot the pattern, it's easy. The answer is 1 circle's circumference plus 5 diameters. There's a general formula for this problem. I'll derive it starting from simple cases. First, 2 adjacent circles. These straight lines each equal 1 diameter. They are tangents to the circles. A radius drawn to point of tangency meets the tangent at 90 degrees, and these curved parts together make 2 semicircles. Therefore, the perimeter is 2 semicircles plus 2 diameters, which equals 1 full circumference plus 2 diameters. Now, consider 3 adjacent circles. The straight lines each equal 1 diameter. To find out the curved parts, we are going to determine the central angle. Join the centers with straight lines. This is an equilateral triangle. So, these angles are 60 degrees, and these angles are right angles. This angle totals 240 degrees. So, the remaining central angle is 120 degrees. Each arc is 1/3 of a full circle, and there are 3 such arcs. Together, their central angles add to 360 degrees, 1 complete circle. Therefore, the total perimeter is 1 circumference plus 3 diameters. Here's the case with 4 adjacent circles. Draw radii to the tangent points. Each straight part is equal to a diameter, and each curved part is a quarter of a circle. With 4 such arcs, their total length is again 1 full circumference. So, the total perimeter is 1 circumference plus 4 diameters. Do you see the pattern now? For n adjacent circles, the total perimeter can be written as 1 circumference plus n times diameter. Here's why. The straight parts of the boundary correspond to the perimeter of the n-gon, formed by joining the centers of the circles. Since each side of this polygon equals 1 diameter, the total length of the straight parts is n times diameter. Now consider the arcs. Each exposed arc corresponds to a central angle. One central angle equals 180 degrees minus 1 interior angle of the n-gon. Therefore, the sum of the central angles is n times 180 degrees minus the sum of interior angles of the n-gon. But this is n minus 2 times 180 degrees. Substitute this. The sum of central angles equals 360 degrees. No matter how many circles there are, the exposed arcs always add up to 1 full circumference. Thus, the total perimeter is 1 circumference plus n times diameter. This result holds under the following condition. No 3 circles or more lie on a single straight line, and each circle must touch the boundary. Let's apply the formula to the original problem. There are 5 circles. N is 5. So the answer is 1 circumference plus 5 diameters. This is the answer. Look at another figure. 5 circles are connected in the shape of a regular pentagon. Still, the total perimeter remains the same. 1 circumference plus 5 diameters. Once you recognize the pattern, the solution falls into place. I want to know what pattern you spotted to solve this problem. Thank you for watching. Please subscribe for the next math trouble.